Hey everyone, and welcome! So today, we're diving into an idea that is genuinely, well, kind of mind-bending. It's this idea of a hidden rhythm, a secret pattern that connects things you would never, ever think to put together, like the birth of stars, the way trees grow, and the very structure of our own minds.
So let's just start with that question. What do stars, trees, and brains actually have in common? It sounds like the beginning of a really weird joke, right? You've got this massive ball of fusing gas, a living plant, and the 3-pound universe sitting inside your skull. What's the link? Well, it turns out there is a link, and it's a deep one. They are all expressions of the same universal logic.
Okay, look at this. This slide kind of lays out the whole puzzle for us visually. Notice you've got these two different patterns. In pattern A, you have things like stars and trees, systems that grow in these really complex, branching, almost chaotic ways. Then in pattern B, you've got things like planets and animals. They're more self-contained, more bounded, kind of like neat little packages. This difference is everything, so just hang on to that idea.
And here's the thing. This is not a coincidence. This isn't just some random observation. There's a new model that suggests this dual pattern is a fundamental rhythm of how intelligence itself gets organized, and it's a rhythm that repeats at every major turning point in the history of the universe.
So how do we make sense of all this? To really solve this puzzle, we're going to need a key. And that key is a really powerful concept called intelligence frame theory, or you can just call it IFT.
So IFT proposes something pretty radical, that intelligence isn't just something that happens inside brains. No, it's a universal process that happens inside what it calls frames. You can think of a frame as a kind of playing field for intelligence. It's defined by what it's made of, that's its substrate, and the rules of the game that decide what succeeds. Those are its selectors.
Okay, let's really dive into this, because this is the big reveal. This is where it all clicks. IFT argues that within each of these major frames, intelligence moves along two totally distinct paths. And these two paths perfectly explain that mystery we started with. So the first path is what we call type 1, or fractal emergence. This is intelligence that grows through these beautiful, self-similar branching patterns. Think of a tree's branches or the connections between neurons in your brain. It's recursive, it's organic, and it's deeply tied to what it's made of. The second path is type 2, modular detachment. This intelligence is more bounded, it's layered, it's separate from its environment. Think of an animal or a piece of machinery.
And boom, this chart just lays out the solution to our puzzle perfectly. In the cosmic frame, stars are that messy, fractal type 1 intelligence, while planets are the contained type 2 forms. In the biological frame, you've got trees and fungus as type 1, while animals are type 2. And then we get to the cognitive frame. Our own brains are a classic type 1 fractal network, while the technology and culture we build, including today's AI, are perfect examples of type 2 detached systems. The pattern just repeats, again and again.
So now we know what the pattern is, but that just leads to the next question, right? Why does this happen? What's the engine that's driving these incredible shifts from one frame to the next?
Well, according to IFT, the driving force is that selector. It's the filter that determines what lasts and what fades away. And the selector itself evolves. It starts out as just the fundamental laws of physics back in the cosmic frame. Then for life, it becomes the physical environment, natural selection. But then, with the rise of brains, the selector actually moves inside our own heads, becoming our ability to simulate the environment.
So, the crucial point is this. For intelligence to make a huge leap forward, it has to break its own rules. There's this idea called the frame discard hypothesis, which says that once a form of intelligence has figured out everything it can do in its current playground, it's forced to throw out the old rules to keep moving forward. It's kind of like a rocket jettisoning its boosters to get into orbit. You have to shed the old to reach the new.
So how does all this apply to right now? Well, it brings us right to the present day, and to the future of artificial intelligence, which FT says is taking place in a new frame, the generative frame.
And if you think about the AI systems we're all talking about, like large language models, they fit this pattern perfectly. They are classic type 2 intelligences. They're built in these neat modules and layers, they're detached from any physical body, and they operate on the scaffolds of our culture, our language, our data, our code.
So, what comes next? Well, if the pattern holds, the next great leap in AI won't be another one of these type 2 systems. It'll be a return to that messy, fractal type 1 emergence. This slide shows two different ways we could go. There's the hard way, building AI like a traditional computer, a Turing machine that relies on symbolic logic.
But then there's the natural way, something called General Transformational Sufficiency, or GTS. And this idea is wild. It's about creating systems that compute directly in their physical parts. So instead of writing software for a computer chip, you design a material that is the computer. It would solve problems by changing its shape or its chemical state, kind of like how a brain thinks or a seed grows. It's less about building a machine and more about cultivating a natural system.
And that leaves us with a fascinating and pretty provocative question. Does the future of intelligence lie not in building ever more complex machines, but in learning how to grow systems that mirror those beautiful, fractal, emergent patterns that we see in stars, in trees, and in our very own brains? The hidden rhythm of the universe seems to be suggesting that the answer just might be yes.